Okay, hi everybody, welcome back from the break. The next talk in this room is from Colin Mulliner. It's called Advanced Attacks Against Pocket PC Phones, and he will now show you how you can own such a phone using an MMS. Enjoy.
So, hello everybody. Hello? Hello? Okay. So, the talk is was already like 6 months old. I did the first version of it at DEF CON, but yeah, I guess nobody read the slides as usual, so new stuff for everybody. So, yeah, this time, actually today, right after the talk, I will release the full source code to the exploit with all necessary tools, so you can have some fun. Yeah. Okay, what's the talk about? So it's about attacking pocket PC, smartphones, and the vulnerability analysis of phones or smartphones, and what's necessary to actually do some fuzzing on a phone. So we're going to fuzz and look at the MMS service, and in particular the client side, so the thing that runs on your phone. Yeah, first we're going to show you the current state-of-the-art attacks against mobile phones and smartphones. Very, very short overview over Pocket PC. Then we're going to look at the multimedia messaging service, and then we do some testing. And then I show you how to own a phone via MMS. And then we have some conclusions and maybe some discussion later. So the basic state-of-the-art attacks is, one is Bluetooth, where you basically take control over a phone, so you can initiate calls, send MMS, send text messages, steal some data like the phone book, maybe the nude pictures on your phone you made from your girlfriend. So watch out. And some denial of service attacks. And of course, there are all those third-party applications from all the hobby programmers which didn't think about security. So you can do some, maybe even some code injection, of course, denial of service attacks. Some fun, but we can do better. So of course, there were like earlier attacks against MMS, which were not really attacks against MMS, which just used MMS message as an transport mechanism for installing malware, Trojans, and most of these worms were written for Symbian, and they required a lot of actual user interaction to actually, before the worm or whatever is finally installed and running and is able to spread, which is from an from a serious attacker's view, not too cool. And the basic, the most common examples are ComWarrior and the Mabir worm. So, and there are these older SMS-based attacks which are really, really super lame, but they work. So there is like this Nokia V card, like the business card thing, which has really a format string vulnerability in the parser. So fun, but yeah. And the Siemens crash because you have an unusual. Sorry for that. Some unusual characters in an SMS message. And the phone basically crashed or reboots. If you have any questions, just call for the microphone guy and ask. I won't bite. So of course, other people before me looked at Pocket PC and what they can do to attack them. And of course, again, third-party applications like FTP servers were exploited. There's actually a very nice buffer overflow in the Bluetooth stack of Pocket PC, where you can actually already do real code injection on an out-of-the-box application. But Tim, the guy who founded it, decided to not release it because I don't think it was Microsoft, but whoever wrote the stack said, oh, we're not going to fix it people should buy new phones, so he never released it. It's a really nice attack, and there's a Bluetooth OBEX push attack where you can just bypass the authentication and have full access to the file system. The active sync attack, yeah, it's just a denial of service. And there are these like local attacks, which are, yeah, you can insert an SD card and auto-run application. So, well, it's not really interesting for us because we want to do remote stuff. So, yeah. So Pocket PC is the the Windows CE version that's used on PDAs and smartphones. Yeah, most of you probably heard of Windows CE, and it just stands for the Windows version for consumer electronics. It basically runs on x86, SH, and ARM, but yeah, I only work with ARM-based devices because yeah, most phones, PDAs are ARM-based. And the current version is 5.0 or 5X by now. So, but all the devices I looked at are run 4.2, so the Windows CE.NET. But yeah, so but there, yeah, as I said, like there are many Windows CE 4.2 devices, and so yeah, it's still, so it's not like outdated. So the sample, so some sample devices I was working with is just, yeah, basically a PDA with a GSM chip included. Just turn your PDA into a phone. So yeah, nothing too interesting besides the wireless LAN, which we'll show you later, is really makes a nice attack against these devices. Yeah, the Windows CE OS is pretty bad. They don't have real virtual address spaces. They're limited to 32 concurrent processes. You don't have a thread limit, but normally you don't have a lot of memory, so that basically limits the number of threads. So it's, yeah, the 32 concurrent process. So the limitation is especially interesting for writing exploits, so keep that in mind for later. So security, haha, Windows CE. Yeah. It's a single user OS, or I don't think they have the notion of users. So you can lock your device, but that's optional. Yeah, any process can basically access any resource in the system. So really, once you run code, you can do whatever you want. You can access any file in the file system, start Bluetooth, make Bluetooth connections, access the mobile phone interface. So yeah, there is no real security. So it's kind of funny to have that on a mobile phone. Yeah, I'm not actually going to talk too much about the exploiting techniques, or just very limited, because it's so well covered by now. There was like a good talk at 2004 who started the whole Pocket PC thing. There is, and then 2003 talks in 2005, or actually 2 talks in a paper. So anybody who's interested has plenty of stuff to read. And yeah, Windows CE exploitation, buffer overflows, stack smashing is like on the PC. You overwrite the return address and hijack the control flow of the program, and it's yours. So it's, yeah, just have to take care about the special stuff you have to do on the ARM architecture. But so there are some basic issues. Of course, you don't have a shell, so just like exploiting and running a remote shell, a bind shell, by connect shell, whatever, is not possible. So you actually have to implement whatever you want to do. So if you want to, I don't know, read a file, you really have to like implement the whole thing. So and the slot thing is the other problem. Since you don't have a virtual address space for each application, you have to actually guess in which memory part the application is executing. in order to hit the right return address, where you actually have to do some guessing. The guessing is not as hard if you do some statistics and look, oh, okay, it's basically always the same. But yeah, it's not, you will probably never be able to have like a one-shot, 100% secure way of exploiting a vulnerability. But that's okay, as we will see later. So yeah, the multimedia messaging service, probably like everybody knows about it. Germany or Europe basically known as MMS. In the US they say picture messaging because they don't like technical acronyms over there. So yeah, it's basically a multimedia or a multimedia content transport system. Can like just stuff pictures, audio, video, and of course text in such a message and send it to the other device. But yeah, you can also, of course, include other data, like the Symbian worms just put a Symbian installer in it. So yeah, you can just send whatever you want. And like email, you basically need an infrastructure. So you send your MMS to a server, and that sends to another server, which then sends it to the client. So you need some infrastructure, and yeah, of course, you have to pay a fee for each message, which is also kind of interesting. So that's like the cool explanation they have in their standards with this really pretty picture with this really pretty colors. So yeah, you can put a picture in it and play some sound. So yeah. So the MMS architecture is actually, or the MMS system is actually a total ripoff because it's not a mobile service. It's just like some crappy IP service. You have basically an HTTP server and a WAP gateway, and just transport your data over HTTP and WAP. Of course, you use GPRS for it. And you have an MMF server, a relay, the WAP gateway, which also does some push proxying. I will explain it in more detail in just a second. And you have, of course, it utilizes MMS. So yeah, just like all the crap we actually know about, like HTTP, IP, WAP. And yeah, many people who like play with phones, of course, know SMS and what you can do with more than just send messages. So yeah, in the first picture you see how an MMS is actually sent. So first, of course, you create the message, and the sender basically just opens the GPRS connection, does a WAP post, which is just translated to an HTTP post, which goes to the MMS relay. The MMS relay takes it, does some parsing, stores it, and then forwards it. So it's pretty straightforward. Very easy to implement your own MMS application. Yeah, and the receiving is a little more interesting since it also utilizes SMS. So in the first step, the MMS server wants its if the MMS server is the same for the sender and receiver, there's no another step. But if it's on a different network, the one MMS server from the one network just sends it to the MMS server of the another network. So the final MMS server just like initiates a notification which is sent over the WAP push gateway, which just converts it to an SMS and sends it to the receiver. And the receiver sees, oh, there's a new message. So just do some WAP get, HTTP get, and get the message. Very simple, but costs you like 50 cents each. So MMS messages are kind of boring. They're most structured like email. It's a multi-part MIME message encoded in binary. You have some headers, which is also binary control information. It's really like email, just a little bit different. You have, very boring slide, but you have different message types for each action. So, just for the blogs who really want to go into depth. So the MMS user agent, that's actually the thing we're going to attack. It's the client application, basically. They call it MMS user agent. And the fun thing is it has to handle multiple types of networks. So first it has to understand the whole SMS, WAP push, WAP business, and then it has, of course, the IP stuff, the WAP post and get. And it has, it has to do a lot of parsing. So it has to parse like the SIML or WML for the presentation part. That's basically like HTML. I will show you a little bit more. And of course, like all the image formats and maybe movies, audio. So there are a lot of possibilities for programmers to make mistakes in all these parsers. So so the actual client, the MMS client, is not written by Microsoft. They just bought it from Arcsoft, small company in the US, which really doesn't care about security. I talked to them; they don't care. Or maybe now they do, but they didn't tell me if they do. So and the actual application is called Tmail Access. So maybe you want to start your PDA and look if you have like a vulnerable device. I actually only tested 2 different versions, so maybe other versions are vulnerable too, but these versions definitely are. So if we want to attack something or attack the user agent, we first need to see, okay, what kind of inputs does the user agent have? Because inputs equals possible attack vector. And since we have some infrastructure in the backend which handles each message, we really have to look at the infrastructure, because it could do sanitization. Like if you have like some invalid message, like an email, if the email is in the wrong, the header is there's something wrong, maybe it's rejected. And for MMS it's the same. It looks into some headers and says, oh, maybe no, maybe yes. And so you actually have to like do some testing to actually see what's going on there. And and since we pay money for each MMS, we started implementing like a small virtual MMS infrastructure, so we can do our testing offline without bothering some mobile phone companies' network. And also we save some money, so that's also very fun. And the actual testing, I used fuzzing because no source code available and very fast results. So for the MMS user agent, we have identified the notification. That's the thing that goes over SMS before the actual message is received. A very small thing that fits in one SMS, some header fields. Then we actually have the real message, which is delivered via or received via WAP HTTP GET. And then we have the actual message body, which is I took it as a separate part because the encoding is totally different, and as we found out, most MMS providers don't look into the body, so you can just place anything you want into the body. It's also, of course, carried over WAP HTTP GET. So for the infrastructure, we basically set up a small fuzzer to check what parts of an MMS message are sanitized or validated in any way, because if you find some vulnerability in the phone, but it's in a field that's sanitized, then it's worthless, because if you send it into the infrastructure and the infrastructure just discards it, it's useless. So we did some testing, to see that we have so we can just have like a list of good for us parts of the message which we can use. As I said, we just did like very low profile fuzzing because we didn't want to trigger anything at the mobile phone service provider. And as we found, like the message header is heavily sanitized. Most of the fields are not usable for attacks, but the message body is just, they don't look at it, just all the headers around. So now to something interesting. The new message notification is, as I said, delivered via push via SMS. And SMS also has the notion of ports, basically like TCP/IP. So binary SMS is sent from this port 9200 to port 9000 at 2948. It's an SMS port. So on the Pocket PC there's the push router. It basically routes different push types to different applications, and if it sees like application MMS message, it just says, okay, MMS client, take it. And the fun thing is, who would have guessed how the client gets to know the URL of the actual MMS message? Yeah, they just send like an URL in the SMS which just says HTTP doppelpunkt whatever, yeah, / and yeah, MMS, normally like something like mobile service provider name .mms or /mms, and then some funky looking number. And that's basically, yeah, they just send you, here is an HTTP URL, get it, it's your MMS. So on the fun thing is, yeah, you can also send this notification over UDP to the same port on the wireless interface. That means you don't need MMS to you don't need an actual infrastructure to do testing. So yeah, so here's a packet dump where you just see the MIME type in the beginning, then the phone number, no, the transaction ID, the phone numbers which are not highlighted, the subject, and the message URL. Yeah, your MMS service provider, and then some ID. That's what your phone gets. Just HTTP get me this. So we can use that to actually attack phones already over wireless LAN. We just say, okay, send this packet to this device, and the phone will say, oh wow, there's a new MMS waiting for me. Let's dial up GPRS. And then it makes also this like ping sound, which is very annoying. Especially if you do it like 1,000 times in a row. And the phone, of course, like starts like eating memory. Then it tries like 3 times for each MMS to receive it. Yeah, you can like fill up the inbox. It's quite fun. And yeah, you have to delete even as, yeah, maybe that's only true for my old devices. On both devices, you had to delete each notification message one by one. So click, delete, click, delete. So it's really not fun to delete more than 1,000 messages. So, and the fun thing is, yeah, you can send it over broadcast to the broadcast IP address. So yeah, you don't even need to scan for a device or send millions of packets. It's just like one packet, eat. So, and to attack it, you just need to have a unique transaction ID and content location, the URL. So, yeah, very easy to build yourself, but I was nice enough to release a proof of concept in August. So, yeah, maybe you want to try right now. Maybe somebody is playing with their device online. Yeah. So just a sample screenshot. Your 1,000 unread messages. And of course, the application allows you to like set the sender string and the subject, so you maybe can send some nice message like, hey, update your Pocket PC, or hey, get a personal firewall for your Pocket PC. If there is something like that. So, yeah. So, yeah, since I use fuzzing, I will very shortly explain fuzzing. As, yeah, maybe somebody was to Gadi's talk in the morning, or so. You basically send halfway valid input, or better, almost valid input to a device in order to find any bugs or exploitable vulnerabilities. And fuzzing really is, or for me really, it turned out to be the best method to do pen testing or vulnerability analysis if you don't have the source code. And yeah, so, but the problem here is you have to pay for each message, or we thought that would be a problem because we want to do fuzzing, and that normally means you really want to use a lot of different inputs, so you have to really send thousands. I guess we like, I don't know how many, but yeah, maybe like millions message. I don't know. It was pretty optimized, so. And you don't want to pay like 10 cents or maybe even a cent per message. That's like too much. But as I said, we can abuse UDP port thing on pocketpc to just send our own, to use our, or build our own virtual MMS infrastructure. So you basically take some web server, I took Apache, a web gateway, and something to generate MMS messages. You can really configure in your pocketpc phone. You can just like say, use a wireless LAN interface for MMS, use this server, use this IP, use this port, and then you can just generate a message, dump it on the Apache server, just send the URL, take the URL and send it via UDP, and your pocketpc phone will happily go over wireless LAN to your web gateway and say, yeah, get me that URL, and works like it would over GPRS. So we have a very nice way to do the fuzzing, and that's like really really a major, like saved us a lot of hassle. And because in the beginning we thought, yeah, we have to like spend a huge amount of money for testing, but in the end we didn't. I think I bought some SMS stuff once to do some other testing, but yeah, we actually didn't pay for one SMS during fuzzing. So yeah, I did actually some very, very brain dead, low, yeah, some very stupid fuzzing. I just like looked for basic buffer overflows because, yeah, I'm lazy and I don't want to do string format stuff. So basically I just like take, okay, variable length field, just put a very long string in there. This was like, yeah, almost everything I could find, which is variable length. Then, yeah, attach the Windows embedded Visual C debugger to the target, and then just send a message. Yeah, so yeah, after each UDP message, just gets the message, and hopefully at some point the debugger will say, oh, exception. And if you get the exception, there is it. It's basically like you do fuzzing on your PC, just with a little more stuff involved, like your nice HTTP server, and you actually have to sit in front of the machine because it cannot. I wasn't able to like auto detect if the device like somehow freezed, and because sometimes it would respond to pings, so, and sometimes not, even if it was running or crashed. So yeah, you basically sit in front of your PC, drink some coffee, and press space, next. Worked pretty well. So that's how an MMS message looks. That's transferred from the MMS server to your phone. You have this, in the beginning it's just the binary header again, and then you have, yeah, some text. The green part is actually just, well, a text file which is included in the MMS, and then you have the SIML file, which is again the HTTP like formatting for the message. So it's a multi-part MIME in binary. So as I said, yeah, really the advantages is if you do testing in your own infrastructure, you can really do deterministic testing, because yeah, the phone service provider may be down or may discard your message or do whatever you want, or whatever they want, not whatever I want. So you can really test. Also, yeah, you can really also test parts of the messages which should be otherwise sanitized. Because maybe you're a good guy and you actually want to like find the bugs to fix them instead of just attacking them. So you also want to find the parts that are actually not attackable but would also cause a crash. So you cannot do that in a real environment. And it's faster, like over wireless LAN, there's no delay of the SMS, which could also be delayed by the provider. It's, yeah, I would say like 10 times but maybe it's faster, but at least 10 times. And of course, usage fees. I think in Germany it's like 49 cents per message. So yeah, 100 message or 1,000 messages, that's quite some amount of money. So after a big fuzzing session, you could like, instead of paying the money for the fuzzing, you could like buy like 10 devices or something. Yeah, and like if you're just a student, there's like no way you want to pay that kind of money. So the first bugs, like in the small notification message, it's either sendable over UDP or SMS. There are already quite some number of bugs. So if you make the transaction ID like really long, MMS Composer, like 1.5 also dies, but that's the length for the version 2, and it's just like, oh, whoops. Content location 2, and yeah, unfortunately you cannot use it for code injection, also because the messages are normally very small, so you could maybe include a very small payload, but the bugs, I couldn't overwrite the return address, so yeah. But the fun thing is, the notification flutter tool now can prevent everybody from using email, SMS, and MMS while the wireless LAN is switched on, because everything is in one application, and as soon as you're connected to the wireless LAN, it just sends us one message, and your client just crashes. So maybe for MMS, that's not too bad, because you can switch off your the wireless, but if you want to read email, yeah, maybe over GPS, but it's kind of fun that you can actually like keep people from using a totally another service while using or by abusing the MMS infrastructure on the device. I thought that was like really funny. Then we have some more in the actual MMS message that's transported to the device. In the headers, there are multiple overflows. Yeah, they're kind of interesting, but the problem is the infrastructure and the filtering. So yeah, I didn't look too deep into that. So in the body content, there are like more just plain buffer overflows in a lot of them. But yeah, you cannot exploit most of the stuff in the real world, because the message would never be accepted by the senders or by the attacker's MMS server. So yeah, in the real world you cannot, or maybe you can. Let's see later. Can use it for attacks. Yeah. So because if you like set up your own MMS server, you don't have to actually submit a message. So you can just like build your bad MMS message with like all the nice overflows in there and just deliver it to some client. So what you actually need to do, you just need to send this notification message and say, hey, here's a new message, try and get it. But I did most of my testing in the US, and for some reason, even if I was told the WAP gateway could go to other IPs and just talk to them and get MMS messages from there, I wasn't really able to do it. But actually, it wasn't that much of a focus for me, so I didn't do the testing very well. So yeah, maybe you guys should like test like all the German phone providers. Since I released the source, you have something to do and see if you can actually bring them to, or yeah, if it's possible to run your own MMS server and make, I don't know, T-Mobile, E+, whatever, like the web gateway to actually go to your MMS server. And then you can use like basically all of the attacks I found. But there is SIML, the cool HTML for MMS, totally, I don't know, kind of useless. It really looks like HTML, sorry. But it's basically just some XML-based language. Again, like everybody needs XML, so also the MMS guys need XML. But it basically says, okay, display the picture here, display the text here, wait 5 seconds, switch to the next picture, something like that. And as I said before, the message body is not sanitized, or any kind of validation is happening. So it's really the perfect attack worker if we could only find something there. So that's actually an SIML file, very simple. And yeah, guess what? Why I highlighted these two parameters? Because yeah, the parser is actually vulnerable. You can actually just stuff whatever you want into the tags, and yeah, the parser just dumps it onto the stack for you. Really, really simple. Like nobody ever implemented like parsing fields in HTML, like ID or whatever, source equals something in double quotes. That's like really, really hard to implement. So they have like two parts of the message at least. Like I stopped fuzzing after I found these two. Probably it's like the same parser for fields, but it's really that damn stupid. So we now have something that you can use for an attack. But yeah, to actually attack something, you actually need your own MMS user agent. So something that actually like sends a message to your infrastructure, your service provider's infrastructure. And yeah, so it was actually really, really simple, since I already had the message generator from the fuzzer based on MMSlib, or like on a much improved version of it. And the web client is, yeah, it's basically just, yeah, a stupid web client, like 10 lines of Java. Yeah, sorry for all you guys. If you want to try it, you have to install Java. But I hate it, but I was really too lazy to do it in C if it was just like 10 lines in Java. And then you just use your mobile phone and dial up your GPRS, get the MMS, get all the values for the IPs and stuff for the MMS relay from the how-to section of your mobile phone provider. And yeah, unfortunately, you really have to use GPRS because they block their infrastructure, the block access to the infrastructure from the internet, or just have it on a private IP range. So you have to invest some money into GPRS. So yeah, the first mobile phone remote code code execution exploit. Yeah. Oh, in August it was the first one, so everybody was like crazy. Woo! Yeah, and in comparison with other attacks against mobile phone, it's really code injection execution. It's not a Trojan or anything the user has to execute. You basically have to open or view the message in order to trigger it. So maybe you need some social engineering in your subject line, maybe, or you just want like a new cell phone from your provider, or I don't know. Yeah, some clients, I guess, open the new message by itself. It happened like 10 times on my device. Maybe it's like a stupid bug, or I don't know. But yeah, if it automatically opens a message, then you basically have not even, you have like a really remote exploit without any user interaction. But yeah, you still have the minor complications that apply for Windows C exploitation, the return address guessing. But yeah, it works, and we'll show you why. Yeah. So yeah, open the message. Yeah, I really did it in March this year. So it's kind of old already, but yeah. So yeah, since I didn't release the exploit code at DEF CON, so I had this stuff for like for the like 5 people I knew who could like write Windows C shellcode, because I guess like, oh, maybe they want to do it, or maybe they want to tell me I fucked up. So yeah, that's kind of useless. But yeah, the slot part is really interesting because you actually have 32 slots, but of course some slots will be used by system processes, and maybe you start your application right in the beginning. And yeah, my statistic basically showed me these 4 slots. Actually, there's a 5 which I did find after some more testing, but you can be pretty sure that if you use one of these slots for your return address, you will get it. So maybe you just like send 4 messages, and if maybe your victim is like stupid enough to open all of them because, oh, maybe it didn't, it just crashed. Oh, maybe the other one works. You never know. So yeah, the screenshots is, yeah. I had a very bad digital camera at that point, but yeah, since I couldn't do a real nice demo, because yeah, getting a nice video camera for your PDA is not that easy, and it's a hell of a mess to set it up. So just a picture. So, and of course, I told Microsoft and Arcsoft about that even before DEF CON, and they, oh yeah, thank you, and yeah, we're going to fix it super fast, and oh yeah, and then after 2 weeks, yeah, we have this patch, but all our OEMs need to test it, so maybe, I don't know, maybe we release it whenever, and now nothing happened. There's no updates. I asked other people who always also work with Pocket PC devices and cell phones, and they, oh yeah, we didn't see anything, nothing happened. So yeah, so even if they fix it, I would have released it. So, but now they really have a reason to fix it, and the URL will be live right after the talk. You can click on the file, but yeah, nothing. You cannot download it yet. It really has like everything. Like I have the WAP client, the 10 lines of Java, and all the MMS generators, some prepared shell code, and yeah, and a nice how-to about how to do it. So of course, since I actually did that for getting my master's degree, my professors kind of said like, yeah, maybe we should think about defense, not only about the attacks. That looks way better in your thesis. It was kind of that. So yeah, what you basically can do, you can just like for the notification flooding, you could go and just have a small packet filter on your phone. Then for the MMS message, you may want to run like an IDS on the phone phone service provider side to like even filter the message out before they even reach your network. Yeah, of course, like an IDS antivirus on your phone. Yeah, and then if you manage to run your own rogue MMS server on, you maybe think, oh, I guess they filter notifications because they should be the only one to send them out. So, but of course, no, nobody filters anything there. Why? So yeah. But that's actually what they should do. They should filter binary MMS, especially the notification stuff, install like IDSs, virus scanners on the network. And yeah, for the users, just install the firmware updates when they finally make them available. So yeah, we're almost done. So the conclusions, since it was basically not, okay, I want to attack your mobile phone, it was basically, okay, what do we need to do in order to do penetration testing for a mobile device, and especially a phone, because you have all the infrastructure, and that was kind of a challenge. And a nice thing we found is like this really the attack, for the 2-vector attack against one application, Wi-Fi, SMS, MMS against one application. That was kind of fun. Yeah, we found like 10 bugs. More, it depends on how you see it. If it's another bug or a same bug in another message, and yeah, it's as far as we know the first code injection execution attack against the mobile phone. And yeah, if we see more stuff like that, it will be a real pain in the ass if you constantly have to worry about your phone getting a worm maybe. So yeah, of course, in the future, maybe we want to look at other parts of the multimedia content, because I didn't even start looking at like image or movie or whatever parsers. And there's like a whole lot, especially if you consider that Microsoft basically just ported like their stuff like all the image libraries to Windows Mobile. Like, does anybody remember the WMF bug, this Windows meta file? Maybe the same implementation is on your on the Pocket PC. I haven't tried because, like, yeah, we want to show our point and do our fuzzing, and that's yeah. So more and more MMS user agents are out there: Symbian, PalmOS, and now maybe in the Linux phones. Yeah. So and yeah. And the MMS infrastructure. We did like some really minor fuzzing and we played with it a bit, but I guess there are many, many more possibilities if you maybe think about spoofing MMS or stuff like that. And of course, yeah, Windows CE 5, which I want to look at and yeah, yeah, I've done some reading, but I haven't got a device yet. But that should be really interesting, especially because Microsoft claims it's so super secure. And yeah, so I'm working on that, and that's basically it. So so questions? Everybody is stunned and like, oh, need to switch off phone fast. Microphone? Or speak up. The URL for the download? Sure. I guess you want that one. But if you just go to my Pocket PC section, there are the links. I will put there a link and to the stuff and the slides right after the talk. So yeah, happy downloading. And don't try to download it now because the file is not readable by the web server as of now. So you have to wait like half an hour. And yeah, I guess more question, otherwise, yeah. Okay.